I'm Malcolm Sparks. I'm the CTO of JUXT, and this talk is perhaps part two of a recent interview I gave on the Clojure Script podcast. That's season 4, E23. And in that episode, I talked at some length about some support libraries I've been putting together over the last 2 years or so. This talk is more practical. It's about bringing everything together to create a ring handler. So if you have any questions, please put them on the chat as we go, or we can have some Q&A at the end. So as John has reminded me this afternoon, I've been banging away at this topic for far too long now, but I do feel I'm finally making a bit of progress, or maybe I'm wrong. But look out for some future REST talks in the next few years. But the progression from, I think that, the 2009 to 2021, it's really been a bit of an obsession for mine of trying to create semantically correct REST services, and it's actually a deceptively hard thing to do. So perhaps that reflects how long it's taken me to sort of figure it out, and I'm not there yet. But before we begin, let's recap and remind ourselves what REST is. It's defined as a set of architectural constraints, and this is the set. What I'm going to focus on today is very much an underappreciated constraint called the uniform interface. Now, REST is not without its trade-offs. It's not as efficient as GraphQL or gRPC, but what it loses in efficiency, it gains in simplicity and encouraging decoupling, which we all know is a notable characteristic of a good systems architecture. I'll just leave you to read this quote here by Roy Fielding, who's the author of the HTTP specification and the author of the paper that introduced REST. So REST benefits, the other benefits I can think of, the broad reach. REST is supported by so much software out there, not just browsers, hundreds of other things. Discoverability is something that is very important in GraphQL with the introspection, something that is built into REST too. We can tell clients what they can do, and when they go wrong, we can use error codes to tell them what they did wrong. Caches that are built into the web protocol now yield great performance. And with security, web standards have such close scrutiny from a huge community of security experts. You can leverage all of that experience, read blogs, guides, and so on to improve your security. It's an ongoing process, but you're kind of in a really good community. I think that, lastly, the benefit for me in REST is the options. Once you've built the foundations right, and this talk hopefully will kind of explain a little bit by what I mean by that, it opens up this vast treasure trove of options. You can have, I've experienced WebDAV, JSON API, OpenAPI, linked data, and much, much more. There are hundreds of RFCs that build on these foundations. So, quick note on terminology. We've all seen URLs before. A URL is the Uniform Resource Locator. But what does a URL do? It locates resources. In REST, resources are, to all intents and purposes, invisible. We can see, touch, well, we can't see, touch, hear, or feel them, but we can interact with them. And the way we interact with the resources is via a representation. So what is a representation? Well, it's a blob of data, and when we transfer representations, it helps that we also send the information about what we know about the blob of data, such as its format, language, compression, and so on. But here's something that isn't obvious to many developers. A single resource might have many different representations, or a single representation, or none at all. So onto semantic correctness. How do we get an implementation of HTTP that is correct according to the spec? Quite a long time ago, I used to use a language called Erlang, which had a framework or a library called Web Machine, and it popularized this flowchart. I think this flowchart predated Web Machine, but it definitely influenced it. It also influenced Clojure library, Liberator, which was based on the same idea. And this was for me the first introduction that there could be a scheme, a set of steps that you could follow to implement HTTP. What you do with this flowchart is start at the bottom left and work your way up and make decisions on various at various points. I think, you know, the problem is that this flowchart, it isn't complete, it's not very accurate or comprehensive, and it's not all that helpful. It's just decision points without much explanation. You have to do a lot of work on top of this to understand what to do at each point. Not everything in HTTP fits neatly into a flowchart. So the scope of this talk is going to cover the RFCs that I'm talking about are listed here. We're mostly going to cover semantics and content. We're going to implement conditional requests. We can also do range requests. I'm not going to cover that too much in this talk, nor caching and authentication, or while we'll mention it, it really does deserve another talk. So before we get started, I wanted to talk about a few years ago, there was a lot of fuss about inversion of control. You'd have these IOC containers and frameworks, and people talked about the Hollywood principle. But in this metaphor, you don't take the role of a successful Hollywood casting director, but the struggling actor desperate to catch a break. So the approach I'm trying to talk about today is more of a DIY approach, where you keep hold of the thread. And I'm defining framework here to mean imported code that asks you to register callbacks with it. This is a difficult lesson for me. I'm attracted to frameworks. They definitely save a lot of time to begin with, and I've even authored a few. The trouble is, you always end up fighting against the framework. There's always something you need that it doesn't provide, and when that happens, you end up doing these crazy workarounds. So today I'm introducing a new concept called IOC, inversion of control. So let's proceed with this new approach by breaking up into steps. Now there are 15 steps here. There's nothing special about that number. This morning it was 16 and tomorrow it could be 17, but the general flow is pretty much stable at this point. These 15 steps are going to provide a very high level of semantic correctness. So I know what you're probably thinking. It all sounds like quite a lot of work. I'll wait until somebody comes up with a library or a framework that I can use. That's fair enough, but if you do follow these steps to produce a ring handler, this might just be the last ring handler you ever have to write. You can use it at every endpoint, on every project you work on from now on. It will be something that you can tinker and tweak and adjust, but as long as you programming Clojure and HTTP is still around. Okay, so before we talk about step one, I want to explain that we're going to build each step as a separate ring middleware so that we end up with a stack. But just so you know, we don't have to use ring middleware, but it's what most Clojure developers are familiar with. But we could write these steps as interceptors. We could run them in an asynchronous chain. We're just not going to cover that today because it would complicate things if we did. So this is what our stack of ring middleware is going to look like. The one on line 3 isn't a step, but rather we're going to make use of Ring's new namespaced keywords in our steps, just so that we don't get them confused with other keywords. Since no web servers right now support Ring's new namespaced keywords, I've added a little adapter to convert between the namespaced ones and the non-namespaced equivalents. Okay, so on to step one. This is what step one looks like. We're going to start off by initializing the request. So if you're not familiar with what a ring middleware is, it's essentially a function that produces a function that produces a ring handler. So what this allows you to do is wrap these ring middlewares into like a chain, into kind of a big group of like a Matryoshka Russian dolls. They can all kind of fit in within each other. So the first step is that we're going to take the request and we're going to stuff it with extra information. Now you can put, I put start date and a request ID, and I've worked out the absolute URI here. You could create, you could stuff in anything you like. You might want to put a database connection in there, or other resources. It's completely up to you. So we do that, we take the extended request, and then we're going to pass it to the next step in the chain. Okay, the step 2, this is to return a 503 response if the server is busy. We do this because if the server is really too busy, then there's no time to lose. There are a number of strategies to accomplish this, but we're going to skip this and move on to step 3. Okay, so step 3 is called method implemented. And this is where we look at the request method and we see if we recognize the request method. And if we don't, we're going to send a 501. So on line 3, in my implementation, I'm supporting the main HTTP methods, plus I'm dabbling in patch, and I'm also beginning to read up on WebDAV, and I want to support WebDAV. So I've got a couple of more methods there, nutcall and propfind, and there are more, but you know, I'm not yet done. So these are the methods that I support. So if the method that came in was from the request was none of these, then we say, okay, 501. And I'm throwing an exception here because they make for great quick exits. It's the cost of throwing exceptions in Java is low enough for this to be a viable solution. It certainly simplifies the discussion and the code. Okay, we're step 4 out of, was it 15 steps? So step 4 is to locate the resource. Now the resource in this case is going to be a simple Clojure map. The Clojure map is going to represent the resource's state, but also the resource's configuration. Now, these words are used in the HTTP RFCs. The state is the current state that the resource is in, and the configuration might be some metadata about what the resource can do. For example, what methods it will support and allow. We can use multiple strategies here. We've just got to come up with a map. So we could look at the URI and use a router to route towards a predefined map. Or we might look at the URI or something else and do some pattern matching or some regex. We could also, in some cases, take the URI and look it up in a database. This is something that I do, or we could have a hybrid approach. And another thing we could do is just generate this map out of some code. So this is the locate resource function. So I've kept things pretty simple here. I'm saying that I've got a request URI, which is /weather, and I'm going to return a map. If the path is matched to /weather, we're going to return this map. It's got an identified description. The resource state here is the current weather, so it's overcast, 16 degrees. And the resource configuration here, there can be lots of things you can put here, but I put the methods. These are the methods that are supported on the resource. Okay, now the line 15, we have the ring middleware for this, and this is going to simply call the locate resource, add it to the request on the resource key, and then call the next handler. Okay, step 5, I call redirect. This is where we look at the resource and say, well, if there is some configuration of the resource is saying, I'm not here, but I'm pointing at something else, now is the time to do the redirect. So what I'm doing here is looking at the method, and if the method is a get or a head, then we should return 302. Otherwise, we should return 307. And that's the second thing we have to do with a redirect is set a location header. And here we reach straight into the ring response headers, and we just set the header. We'll set any headers we like in this approach, and we throw the exception. Notice that at each time that we throw the exception, we're taking the entire request, which is now quite a big map of data, and we're throwing the whole lot updated to the exception handler. This approach of taking a map, and think about it like a snowball, it's getting bigger and bigger and bigger as it goes through the chain. All the information that you need, whether you're working out, doing some debugging or logging, is there available in the map, and that's kind of one of the advantages of this approach. Okay, step 6. This is called current representations. We only do it for get, head, and put. The job of this step is to return a collection of representations. Many times the representations will just be a collection of one representation. That will be the most common case. And for a representation, we're also going to use a Clojure map. This is a declarative approach, and we use maps for everything. Okay, so what does a representation include? Well, it includes information about the body, the blob of data itself, or how to, it might be a generator that can create the body, or some information about how to find the body on disk or in a database. But it will also contain some representation metadata, as much as we can possibly know up front. Typically, that's the content type, the content length, it could be many other things as well. In the case for get and head, if we don't find any representations, we throw a 404. And a 404, what it means is there are no representations, no available representations. Now, this is doesn't mean the resource doesn't exist. I mean, technically speaking, on a put, the resource could have no representations, but you're about to put one in there, so the resource kind of does exist. So 404s are really, don't indicate the resource doesn't exist, just that there are no current representations. So in my example here, let's have a look at this. With line 2, we're taking the resource out that we found in step 4. We then look at the ID. We could look at anything in this resource. It could be the URL, but you know, it's better to dispatch on something you know about the resource. The URL might change, and so, or it could be a short link or something. So better to dispatch on something that you can be confident won't change. In this case, I've chose the identifier of the resource, which is the weather. Okay, now here we've got 3 representation maps that are being returned in this collection. The first 2 are HTML, one in English, one in Spanish. See, I've put the content length because I might happen to know it. And in the third example, I'm returning a gzipped JSON blob to a machine, presumably. Okay, so what does the middleware look like? Well, first of all, we look at the method. If it's get, header, put, remember this is only for those methods, then we get the current representations that we found in the previous step. Now, if it is get on head and the current representations is empty, we need to throw our 404. Otherwise, we just attach it to our snowball as any key you like, but I've chosen cur reps. And then we go to the next step. Okay, step 7. Step 7 is content negotiation. Now, content negotiation is quite a large topic. It's complex. Last summer, I developed a library called PIC, which I spoke about on the podcast. PIC is an implementation of the Apache content negotiation algorithm. So it implements all the things that you have to implement in terms of scoring and queue values and wildcards, and on multiple axes, which is content types, content languages, encodings, and char sets, and then uses the Apache content negotiation algorithm to decide which prioritizes over the other. It's quite a complicated process, and but beyond the scope of this talk. But the point being that if you know the request and now you know the current representations of the choice, you can ask PIC to pick the representation that makes sense. Here, PIC takes on line 8. This is the call to PIC. We have there's an option map. One of the options you can give it is to ask PIC to generate the vary header. Now, the vary header in HTTP tells you which axis is varying, so that you can potentially ask for other representations. It's just all described there in the RFC. Now, in the case of get and head, if we don't find any representation, we have a choice. We can just pick one to throw. In this case, I'm saying I'm going to return a 406. This is saying to the client, there are no representations. that are acceptable given your accept headers in your request. Again, we don't have to, we might just say, or pick the first one, but we pick will give you a report of all of the scorings and all the ones that are acceptable, and of all the ones that are unacceptable, the best ones to choose. So again, that can be for potentially another time. The important thing here is that we take the very header. If we get to line 20, we know we've found the right representation. Okay. So here we are, the ring middleware. We get the request, the current representations at the request, and we then negotiate the representation, and the result that comes back we'll put into this selected rep. So now we've gone from multiple representations to just one. That's the selected one. Okay, almost halfway, we're halfway through. Step 8, authenticate. So step 8, the job of authentication is to check that the request is authenticated, and we try to work out what the subject is. Now, the subject might be the username, roles, company the request came from, authentication method, IP address, all that kind of stuff, so that it represents the user behind the scenes as making the request. Now, you might have a username and password database, or you might decide to use an authorization server, like Keycloak or Cognito or Auth0 or Google or many others. So at this point, if there is no subject, you can't authenticate the request and you need to, this is the time to redirect off to an authorization server, have it redirect back to you, set a cookie. If they're authenticated, the cookie might encompass the subject. You might use a JWT, or you might use a database and a session token, and you'll set that cookie and wait for them to come back in. Okay, so we're not going to cover all of the kind of vagaries of login forms and things like that today. We're just going to say that all that stuff is in step 8, authenticate. So in my authenticate function, I've left it blank, but I've given a few hints about what you might want to do. Importantly, we're not going to authenticate if the method is options. Options is used for various things. One of the things is a CORS pre-flight request from a browser, and you can't deny that request because then it won't work. So often we don't authenticate in options. But if we do find a subject, then again we put it into the snowball, and the snowball gets bigger, and then future steps can refer to that subject. Okay, just see if there are any questions on the chat. No. All right. Step 9, authorize. So the job of authorizing. Here we go. So step 9 is to authorize, approve, or deny the request. This is where, if we might make a decision about whether the request is allowed. If it's something where the request hasn't got subject and there hasn't been an authentication or subject provided, we would send a 401 saying you really need to authenticate. But if they already have authenticated and we've made the determination that they're just not authorized given their rights to interact with this resource, then we'll send them a 403, which really means don't even try re-authenticating. Your subject is okay, it's just that you're not allowed to look at this resource. Now, there are, again, lots and lots of things that you can do for this step, lots of options and how you make this decision. Recently, I've been looking at a authorization technology called XACML, which comes from the XML community. It's incredibly verbose, but it has some really, really great concepts. There are other logic-based languages around, and there's a good link here, Open Policy Agent. We've been building in JUXT for a project, a policy decision point, which is an XACML term, which means a point where you run a load of rules and you determine whether somebody's allowed to proceed or whether they need to be denied. And we've implemented that in Datalog. So I want to show you a couple of Datalog rules. Now this is Crux Datalog, but it gives you a kind of flavor of what you should do when you think about authorization. So authorization can take into account all kinds of things, not just the request, but attributes of the resource, what the user is trying to do, whether they're trying to read or write or delete something, the level of security they have, and maybe lots of other things within the database, the configuration and environment. So what we do is, when we have an authorization request, we take the request and we speculatively put it into Crux, we inject it into Crux, and then we take any kind of the environment and the resource and anything that we've captured in the snowball, and then we run a piece of data log on Crux and ask it questions. Now, the data log has access to the entire database, so we can, there are no limits. And this isn't like we have to do an extract of all the data and upload it to some third appliance or PDP on the network. This is running right in our node. So these first two rules, the first rule is saying if the request method is get header options, and if the resource has a keyword, an entry of classification as being public, then it's a public resource. We'll let the request proceed. And the second example was saying if the resource has a classification of internal, then there needs to be a logged in subject. And what we're saying in that line 9 is that the subject has to exist. Okay, authorization is a big topic, but it's one where you really want to have full control. This is one area you don't want to be limited to what a particular web library or framework will provide you. You kind of really do want the control. So step 10, we're over halfway. Method allowed. So this is quite remarkable that very few web frameworks support the idea of a 405 response. 405 means no such method not allowed. In particular, if you use a router and you route at the method level, so you dispatch between get and put and post, it's really hard for those functions to know which other methods are allowed and which aren't. So perhaps that's why 405 isn't really implemented. But in this middleware, we're going to introduce a function called join keywords. This is going to take some keywords. It's going to root out any duplicates. It's going to turn them to uppercase strings and join them with commas. So that's typically allows us to keep collections of keywords in the snowball, but HTTP insists that they're comma separated on the way out. So we can use this. Now, line 7, we have the ring middleware. We're going to check that you remember that HTTP methods entry on the resource. We can look at that, and now we can say, well, is the request method in that set? And if it isn't, then it's a 405. Now, 405 responses must have a header saying allow. You've got to tell the client which methods are allowed. And we're going to keep that for later, because options, when we implement options later on, that also has to have an allow header. So we're going to just, having calculated it, we're going to hold on to allowed methods. Okay, next, step 11. This is the big one. We've done all of the request checks. We're ready. We're now ready to perform the method. We know the method. Is it a get, post, call? Up to you. This is a very simple function that does a case statement and then dispatches to the right method. So let's have a look at some of these implementations. So get is going to first call a function called evaluate preconditions. We're going to see that later on. This is covered in RFC 7232, and it is about allowing those cache headers to, it allows us to very, very quickly determine if we don't have to do anything. And this is kind of one of the performance features of this approach. So what we're going to do is we're going to, this is a 200, everything's gone right up to now. And then if there is a body in the selected representation, we're going to just associate it on. This is the time where you would say, well, if I've got some mechanism of going off to a database or a file system or generating the body if it's a report, the clues, the data you need to make that determination would be in the resource, or in the representation rather. And the representation then your code would take over and say, aha, I've got to do this, I've got to do that, and I'm going to generate the body. So this is the time that you would do that. You might call into a templating library and so on. For the post, this is very different. The first responsibility of the post is to receive what might be a body coming in, a representation coming in through the request. We'll cover this again in a few minutes' time. But then the received representation now gets added to the snowball. In this design, at least, I am kind of registering a kind of function on the resource. There are other ways of doing this, just the clues, and this is the simplest thing. You might use a multi-method. This is saying if there is a function and it's a post function, then just call it with the snowball. Otherwise, it's an internal error, and we'll send a 500. Put, very much the same. We're going to do the same with put, although we're seeing receive representation, but the semantics of put are quite onerous. Delete, here I've just copied and pasted a function from another code base, but this is us using Crux. Actually, we're going to map this delete call onto a real delete within Crux, and then we'll submit the transaction. And because Crux is asynchronous at this point, and we're not going to wait for that transaction to complete, we don't know that it's going to work, but there is a response code that we can use to reflect this in HTTP called 202. We can say, well, we've accepted the request. If we did actually wait for the transaction to finish, we could say 204. If you look at the RFCs, it's 202 and 204 are the most common responses that you should send in response to a delete request. Okay. There's a question, could we not look in the cache earlier if we had a way of validating that no rules have changed? Yeah, we are going to come on to the conditional requests, but with caches, the way that they work, that they will hold on, you indicate through your representation metadata things like how old a response is allowed to be in a cache, its expiry, its age, and whether it should be cached at all. And what a cache does is wait until that response has expired, and then it will go back to the origin server with a conditional request and say, hey, is this response still valid? And then the origin server can very quickly, maybe just checking an E tag and doing some string comparison and say, yeah, actually, you're still good. So I'm not going to go into all the different strategies for making that fast, but caches work very harmoniously with this approach, as long as you have the opportunity, which you do, to set the representation metadata ahead of time. You might decide that the agedness or the staleness of a representation is a function of the configuration of the resource. Again, you have control. You can put anything in a resource you like. Okay, we can talk more about caching at the end. Okay, nice to see Chris Jenkins used XHTML back in the IBM days. It'd be good to hear what you thought of it, Chris, at the end. Okay, very good. Preparing the response. So we've got 4 steps to go, right? Preparing the response. So we've done the method. Oh, hang on, have I done all of the, I don't think I have. Hang on, we just skipped ahead a bit, I'm afraid. So we're on delete. Okay, options. This is where when we're implementing the options, I mentioned the allow header. You can also do many other options. I'm not going to go into cause pre-flight requests, but this is how they're achieved. You can support cross-origin calls from other from browsers. If you can implement the pre-flight request, you just have to compute some additional headers. Those are not specified in the RFCs that are in scope for this talk, but you can look them up, and this is where you would slot that logic in. Okay, this is where step 11, we're still on step 11. I mentioned evaluating preconditions. These are defined. The benefits of these is that they absolutely make the caches sing. If you can do this fast, you can take a lot of load off your servers. And it will also, on the case where you're doing a read-write server where you're allowing puts and posts, it has mitigations for the lost update problem. That's when you've put something in that you want, and then somebody then overwrites what you've put in with another update, but they didn't realize that you've just overwritten, so you lose your version. It's kind of a race condition, and it's caused by people having stale data. So this is a kind of a great mitigation for that. Okay, so this uses representation metadata. So I'm not going to go into all the logic, but this is kind of what it looks like. And you can copy and paste from the code base that I'm going to explain at the end. So here we only do this we don't do this for connect options or trace. That's just written into the RFC, and this is the order. This is actually just a kind of this is written almost as it's written in the RFC as the series of steps. So kind of we don't have to think about this. We'll just copy the RFC. Okay, the second kind of helper function that we talked about is receiving the request body. So these are the steps that you have to do. You have to check what there's no content length at all, no content length header, return a 411. It's a bad content length for somebody's foo, that's a 400. If the length is too large and you're willing to support, what does that mean? Well, that could be a resource configuration or something, or then it's a 413. If there's no body at all and you're expecting one, it's a 400. If it's an unacceptable content type, so this is somebody posting in something, maybe you're kind of an image server and you're just supporting images, and somebody posts some JSON, I don't want JSON, then it's an unacceptable content type, 415. But not for content encoding or content language, then it's a 409. And then this is kind of a footnote, but if there is a content range header in that request, you've got to send a 400 because it doesn't make sense to put a partial resource. So anyway, that's a good test for whether you get semantic correctness or not from, test your library, send it a content range header in the request and see if it returns 400. If you finally get through all of those checks, then you can select the body and return it, put it into the snowball. Okay, step 12, preparing the response. We're finished now. We've done everything that we need and we've actually done the method. So what do we need to do? Just create the response. We've got to turn all of that representation metadata that we've got in our selected representation. We'll just turn them into headers. Here's a respond function that I'm going to use in the error handler as well. So we're just going to have it as a self-contained function. What I'm going to do is just add a date. You're meant to put date response header on every response, so we'll do it now. Now, if there is a selected representation, we'll then use this representation headers, it's in the next slide, to turn it into a set of headers. And then finally, now we are passing the method through the snowball, so anything generating a body should have looked at the method and said, hey, it's a head, I'm not going to generate a body. But if somebody has, this is the time that we can get rid of it. And then there's the ring middleware on line 19. Okay, representation headers that I mentioned. This is fairly simple. You're just turning Clojure data structures, serialize them back into their response header equivalents. Okay, step 13. Now, security headers. This is a big topic, and I didn't want to run too far. So I'm going to just say a few words about this. This is something that does depend on your context, and you shouldn't let a response leave your server until you've added security headers appropriate to what you're trying to achieve. So this is step 13. What you should do depends on kind of your context. It could be you're supporting a web API that's going to be used in a browser. It could be something on an intranet, or you could be using HTTPS solely, or you might need HTTP. But this is the time where you to ensure that you also add any security headers, and this is also the time you should add those caching headers if you can compute them. Step 14, this is almost the penultimate step. This is error handling. So I'm going to just make a mention for this. So many of the times that we wanted to return non-OK error responses, we've just thrown exceptions. Here's where we're going to catch those exceptions. The X data in this case is the snowball. So we can log the snowball with a message. And then if we can compute, we've got to compute a new error representation, because we might, for example, decide to compute a JSON error. And we're going to make sure that the JSON error is acceptable to the client that we're going to return it to. So this is where we would dive into another round of content negotiation. We might have a whole set of different formats or content types that we can return errors in. But essentially, we call the same respond function, and that computes an error. The 500 is the default. If you look at the snowball may well override that to a 406 or 405 or something. Okay, last step. This is, we're finished our response. We're just about to send it over the network. Just last chance to log it, and we'll use a kind of maybe an Apache logging format or file. I've been using Crux recently, and I'm logging these snowballs into Crux itself, because when something goes wrong, it's really convenient to be able to get the request ID and look at the entire state of the request from front to back and be able to determine what the error was. So because this request blob is just a data structure, you should be able to serialize it. Okay, that is the end of the talk. Some further reading. There is a site I've put up, which is a companion guide to this talk called www.rest.guide. Should give you a clue of what it's for. Then there is I guess I did used to try and keep an example code base going in a project which is kind of deprecated now, called Spin. And what I'm doing is building something called Site. I'm not going to talk about it today, but I decided it's just easier for me to keep these steps coded in a real code base, because that's where my current attention is. And it does mean that it's a working example. It's not a trivial code base. It's a real world code base, but it's certainly all of the steps that we've spoken about today are all in one namespace called handler. So you should be able to tease out how these steps combine. If you want to go back and steal code, you look at the conditional request logic, feel free to completely steal anything you want out of that code base. It's MIT licensed. And of course, I do encourage you to make use of the RFCs, to go read them. They are excellent RFCs. They're the new batch that was sort of rewritten about 4 or 5 years ago. And they really, you can read them over and over again and still kind of pick up new bits and pieces. So, they're quite hard to penetrate to start with, but once you practice and you read them a few times, they're absolutely fantastic resource. This is a quick, you might have seen rest.guide do. It isn't completely up to date. I need to, and it is a little bit of a work in progress. And I have hoped that this might become not just a Clojure guide, but a guide for people doing these steps in another language. I mean, there's no reason why these steps can't be done in Java or Kotlin or Ruby or something. Okay, finally, there is a JUXT site. It's one of the least popular projects on GitHub right now, but you can go there, and that's where all the code that we've seen today lives, although I did simplify it a little bit for the talk. Okay, any discussion or questions? Happy to try and attempt to answer them. But thank you very much for your time and getting this far. It was a long talk with all those steps, so thanks very much for staying with it.